Hello students, welcome back. So in this session, I'm going to show you some of the basic math operations that you can perform on elements that are present inside your NumPy array. So the topics that I'll be covering would be like performing square root or power or log, exponential, round, ceiling, floor, sum, cumulative product, and difference on NumPy array elements. Okay, the first thing you want to do is import your NumPy as NP. All right, import my NumPy as NP. Now let's say you want to perform some element-wise operation. Let's say you want to add or subtract or maybe multiply or divide every single element by some number. Let's say by 10. So let's say this is my array right here. Okay, this is my two-dimensional array of shape 2 by 3. I want to add 10 to every single number. Okay, I want to add 10 to every single number. So let's do that. I added 10 to every single number, and as you can, when I print my result, as you can see, it added 10 to every single numbers over here in this array. All right, now let's say I want to subtract 10. This time I don't want to add 10, I want to subtract 10. Well, you can do that too. You can just say x minus 10. It's as simple as that. All right, now let's say you want to multiply every number by 10. Well, all you have to do is just type x multiply by 10, and that's going to multiply every single number inside this array, this 2D array, by 10. And as you can see, it produces this result. What if you want to do the division? Well, that's simple too. I'm sure you must have figured out by now. All you have to do is x divide by 10. And you do x divide by 10, and that's going to divide every single number by 10, and that's your result right there. Okay, what about element-wise operation of square root, power, exponential, log? Well, we can do that too. So there are some inbuilt methods for each one of them. So let's start with square root. So let's say this is your NumPy array. All right, this is my NumPy array. As you can see, this is a two-dimensional array, and the shape is 2 by 3. There are two rows, and three columns, right? All right. So the way you do square root, you say np.sqrtx right there. Okay, you call this inbuilt method square root x. You run this, and that's going to print out the square of every single number. Okay. What if you want to raise every element? Okay, raise every number over here to the power of 2. Well, you can do that too. You can call this number called power. There's an inbuilt method called power. And when you invoke this method, that's going to raise everything to the power 2. You can raise to the power something else too. Maybe you want to do 3. If you run this, it's going to raise to the power 3. You want to raise to the power some other number, you can do that too. Okay, it's going to work just fine. All right. Now let's say you want to compute e to the power x for every element. Now, by the way, e is a Euler number. Okay, e is a Euler number. Some of you who come from a math background will recognize this. So e is your Euler number, and I want to compute e to the power all these numbers. Okay, all my numbers are in a matrix with the shape of 2 by 3. Well, you can do that too. And as you can see, it computes e to the power 1 is this number, e to the power 2 is this number, and e to the power 3 is this number. And again, e is a Euler number. Okay. All right. Now let's say you want to compute the natural log. Okay, natural log of a two-dimensional array of this of the same shape, like 2 by 3. Well, you can do that too. All you have to do is invoke this inbuilt method dot log x. Okay, np dot log x, and that's going to print the natural log for every single number. Natural log, by the way, it means your the base for your this log is e. That's what your natural log means. Okay, so log to the base e of 1, answer is 0. Log 2, answer is 0.69. Log 3 is this answer, and so on and so forth. All right, now what if you want to compute the base 10 logarithmic? Well, you can do that too. There is an inbuilt method called dot log 10x, okay? And that's going to compute your log to the base 10 for every single number over here. So if you run this, you can see log to the base 10 of 0 is 0, log 2 is 0.301, and so on and so forth. Now let's say you want to perform element-wise operation for rounding. Now there are three different types of roundings in NumPy. There's a floor, ceiling, and regular round. So let's look at each one of them. So all right, so this is my number 1.1. This is my array, and these are my numbers 1.1, 2.2, 3.3, 4.4, 5.5, 6.6. All right, and we want to round each one of them. So let's start with floor. There's an inbuilt method called floor, and what it does is going to round it down. So your 1.1, okay, will become 1. Your 2.2, okay, will become 2. your 3.3 will become 3, and your 4.4 will become 4, and 5.5 will become 5, 6.6 will become 6. All right. So basically, it's rounding it down. That's called rounding it down. Likewise, there's a method which actually rounds up, and the inbuilt method is ceil, CEIL, short for ceiling. So your 1.1 will become 2. All right. Your 2.2 will become 3, your 3.3 will become 4, and your 4.4 will become 5, 5.5 will become 6, and 6.6 will become 7. So this is called rounding it up. You're basically going one step higher. Then you have regular round, okay, which we learned from our high school. So in this case, you have an inbuilt method called roundx, and that's going to round everything just the way we learned in our high school. So 1.1, 2.2, and 3.3, they will become 1, 2, 3. You see, 1, 2, 3. On the other hand, these numbers 4.4 will become 4. All right. 5.5 will become 6. And this one, which one is that? 6.6 will become 7. All right. 6.6 will become 7. So this is your regular round. Okay. So somebody had asked me in the past, hey, what if can we apply all these operations like simultaneously? Can we have chaining? So he said, I want to, for some reason, he wanted to square root all the numbers, okay, and then multiply by 2, and then you want to add 5 to every single numbers. Well, you can do that too. The way you do is, let me just remove this. Let's come over here. Let me just start again. Okay, so he wanted to square root everything. So np dot square root. All right. So he wanted to square root every number. Oh, oh, sorry. Yeah. Let me just go like this. Okay. So he say he wants to square root. So that actually square roots all your numbers. Then he say he wants to multiply everything by 2. Well, multiply by 2. There you go. And then he said, I want to add 5 to each one of them. Well, you can do that too. So you take this thing and come over here and add 5 to each one of them. And that will print your result. As you can see, it prints my result right there. Okay, so basically I'm taking square root of every number, multiplying every number by 2, and then I'm adding 5 to every single number. All right. Now let's say you want to raise every number in an array by some number that is present in a different array. Well, you can do that too. So this is my array A. I want to raise every element over here to the power that is present inside this array. So I want to raise 2 to the power 3. Okay, and the answer is 8. Okay, 3 to the power 2, the answer is 9, and 4 to the power 2, and the answer is 16. And the way you do this thing is using this method, dot power. Okay, np dot power a comma b. You specify your first array, specify your second array. So this is going to raise every element in this array to the power that is present, to the power of the number that is present inside this array. Now let's say you want to find the remainder for every number divided by some number that is present in a different array, which is in this array. So you want to find 10 divided by 3, what is your remainder? You want to find 20 divided by 7, what is your remainder? And so on and so forth. So you can use a method called remainder, or you can use a method called mod. They both have the same purpose. So let's look at this one. 20 divided by 7, your remainder is 6. 30 divided by 8, remainder is 6. So that's how you can get these numbers. Now let's say you want to do some floor division. Okay, you want to perform some floor division on every number. Well, you can do that too. So let's say this is my array. All right, and I want to perform floor division. So this is my array, right? Another different array. I want to perform floor division by 10 divided by 3. What is my floor division? So in this case, some of you who might have forgotten what floor division is, I'll just give you a short refresher. So you have 10 divide by 3. Okay, so let's work with this thing. 10 divided by 3. 3 goes into 10 by 3 times. Okay, 9. And this is 1. So this is your floor division, 3. And this is how you come across this 3. Let's look at this thing, 20 and 7. All right, so 7 and 20. 7 goes into 20 by 2, 14, 6. This 2 right here. All right, this 2 is this right here. This 2. Okay, so this is called your floor division. All right, then Then comes sum and cumulative sum. Sometimes you want to perform sum and cumulative sum. So let's say you have an array 3, 2, 2, 4, minus 1, 6. You want to add all the numbers together. So there's an inbuilt method called sum that's going to add all the numbers together. So you just say print np.sum. Okay, that's going to add every single numbers together. What if you want to track saving growth over time. Okay, so let's say this is your array. Okay, so let's say this could be your monthly saving. Every month, how much money you save. This is how much money you save every month. January, February, March, April, and May. So this is the money you saved. So you can do cumulative sum. What cumulative sum does, it tells you how much money you have, how much money you have up to so far in your bank. So if I do my cumulative sum and if I run this, it's going to tell me this number right here. So for the first month, 100, 100. For the second month, it's going to be 250 because 100 plus 150 is 250. For the third month, it's going to be 450 because 100 plus 150 plus 200 is 450. Then it's going to be 550, which is going to be addition of all these numbers. So this is called cumulative sum. You're basically taking all the previous numbers and you're adding them all together. This is called cumulative sum. Likewise, there's a product, okay, and also there's a cumulative product. So let's start with the product first. So let's say there's a person. Let's say it's you, and you have four outfit options: two shirts, you have three pants, four pair of shoes, and two ties. And you want to find out, okay, how many different combinations of items you can wear, okay, from these different categories. How many different combination of items you can wear from these combinations? Well, if you remember from your high school math, you just multiply them all together. You multiply 2, okay, by 3, by 4, and by 2. Okay, so this is a simple application. So this is where the method, there's an inbuilt method called prod. It's going to multiply all the numbers together. It's going to give you the result. If I run this, it gives me the answer is 48. So there are 48 different combinations that I can have when I have two shirts, three pants, four pair of shoes, and two ties. Now let's talk about cumulative return. So just like cumulative sum, there's a cumulative return. So what cumulative return does, it's gonna take this array. Okay, I'm printing my array first. Okay, it's gonna take this array and then it's going to multiply the previous ones. So this is going to be 1.1, 1.1. This is going to be 1.555 because it's 1.1 times 1.05 is this number. Then 1.1 times 1.05 is 0.98. Multiply all three numbers together. This is your answer right here. And then you take all these four numbers, multiply them together, and this is your answer. So this is called cumulative sum. One of the application would be computing like cumulative returns. Okay, so sometime when you have this like yearly returns, so this is how this is calculated. Then comes one last use case, which is difference function. So let's say these are your array. Okay, and this could represent the number of visitors coming to a website. So you want to calculate like how much is the increase or decrease in your daily traffic. Okay, daily traffic increase, or you want to calculate decrease. Okay, increase or decrease. So what you were basically doing, you're saying 10 and 15, right? You're just calculating the difference, like how is it went up or down. So in this case, there's a function called diff, and what it's going to do is going to take two consecutive numbers and it's going to tell you the difference between them. So one day it was 10, the next day it was 15. What is the difference? 5. All right, then 15 to 30. Well, it went up by 15, right? So it went out 15. 30 to 25. Okay, the difference is minus 5 because it went down, minus 5. Then 25 to 31. Well, the difference is 6 because it went up. So this is your diff function. All right, gentlemen, I hope this session helps. Thank you.